Hello and welcome to Unapologetically Technical. My name is Jesse Anderson. With me today is Neil Avery. He's the CTO at Liquidlabs. We're going to talk quite a bit of depth about his extensive distributed systems, but a little bit about the show. This is the show that's different. It's called Unapologetically Technical. And most shows are just kind of surface level. No, we're going to go all the way down, as deep as possible, as deep as we need to, and we don't apologize for it. That's part of why it's unapologetically technical. So, Neil, welcome. Thank you again. And would you mind introducing yourself a little bit more depth?
Sure. Thanks, Jesse. So obviously I'm Neil Avery at Liquidlabs. I have a long history of working in large-scale distributed systems dating back to the first dot-com boom, where I joined Iona Technologies and found myself in the depths of Corba. And since then, I have worked consistently on large-scale distributed systems, going through the Corba era, showing my age, obviously, into the J2EE and SOA and MOM, into compute grids, distributed caching, Kafka, and streaming, where we are now. So it's been a fun ride. I'm a hands-on architect, or technologist, whatever you call me. I just do tech. So I love coding, I love problem solving, and I like learning. So I think they're all fundamental things that make people good at technology. So thanks for having me on the show, Jesse.
Oh, it's my pleasure. And so we're going to have to talk about Corba because that brings back memories. I won't say they're good memories. They're just memories.
Yeah.
So why are you so interested in distributed systems?
I think it was by chance. I'm from Perth, Western Australia, where the tech industry is not so big, and I just happened to join an Irish company called Iona Technologies and started learning about distributed systems and Corba. And then I think I was in my mid-20s at that time. But I guess the thing about distributed systems is it makes you appreciate, a bit like a deconstructed meal, how everything fits together. It changes your thinking. It makes you fully responsible for all of the various outcomes. And it teaches you some of the fundamentals of how you should think about designing systems, but obviously designing systems for success as well as failure. You know, happy paths are great, but it's also the unhappy paths and the failure scenarios that also make things interesting, and make you responsible. So I think the thing I've found interesting about distributed systems is how we keep coming back to the same fundamentals. So back in the day when I was working on Corba, I was working on an asynchronous protocol. So Corba is asynchronous as well as synchronous. And at that time, we were building everything over UDP, allowing event-driven architectures to be built. And guess what? We're still kind of doing the same thing these days. So I think everything's cyclical. And yeah, I think distributed systems are changing. And as usual, we're seeing revolution after revolution as to how we view and understand them. Hence, data mesh and event streaming. I'm not going to say Gen AI.
I agree with you on the cyclical nature of things. I don't know if you read the Web 3.0 spec, but they're going to be sending the data over UDP. And I thought, oh, wow, that's really interesting. And then I started digging into why, and it'll be more efficient. You have some of the issues of large packet sizes, or well, TCP has smaller packet sizes. You have larger packet sizes. You'll be able to interleave better. Yeah, and basically the sort of things that we were trying to deal with in Corba. Maybe for people who don't know what Corba is, could you tell what Corba is?
Corba was a bit like many things that come out that are tried to be standards oriented. So it's a common object request broker architecture. It's essentially a platform for doing distributed systems. You write an IDL, which is a little spec for what your object is, and then you compile it into the various languages that need to talk to each other. So it can be any language. and it allows all of these objects to have their requests brokered to each other. That's it in a nutshell, but like many specifications, there were many parts to it, and a lot of the vendors would only do certain bits and pieces. So you often found that some features that are part of the spec were not implemented or were implemented poorly. But I guess that's the world we live in.
And I think that kind of paints our picture or gives us the background and how we thought about Kafka. Because as I think both of us were pretty early on in Kafka, it painted our view of Kafka is this good way to marshal and unmarshal objects. And when I talked to people, they were talking about it in a very different way and I disagree with, I think that Kafka is the way to move objects around, not the, or perhaps more correctly, they were thinking of it as an RPC framework, and it absolutely is not an RPC way.
Yeah, I always like to think of, I know obviously Martin Kleppmann came up with the phrase, turning the database inside out. And but if you think of it like a commit log for a database, then it's almost like the database deconstructed, and you can all read from it, and it kind of runs distributed, and it's definitely not RPC. It's a commit log, commit only, append log, whatever you want to call it. It just happens to allow you to write and consume, or produce and consume, those payloads remotely. But I think it's possibly heading down the same path. Oh, actually, no, we can talk about that in a minute. I think where the whole Kafka ecosystem is going.
Yeah, it's definitely a setup for what we're going to talk about with SpecMesh of difference. And that just so people, in case people don't know what an RPC is, it's a remote procedure call. It was the back in the day way from, I guess, when you and I were much younger. And this was how we reached out to a server and said, give me an object, for example, or vice versa. Sometimes the server would reach into the client and pull back something. And that synchronous versus asynchronous, there's a huge difference, not just in performance, but in system complexity when we start doing our RPCs in asynchronous mode or synchronous mode.
Yep. And the architecture that results from that.
Yes. So you have been an architect, and I can tell that your programming skills haven't aged. What do you think makes a good or a bad architect?
Oh, see, that's a good question. And maybe if you'd asked me that 20 years ago, it would probably almost definitely be a different answer. I think what happens is it's easy to read books and learn about fundamentals. And as I always say to my kids, you really only learn by doing. And some people are lazy when they have to get things done, and some people are getting down to fundamentals of understanding why they're building a system in a certain way. And I've been lucky enough to have been the first person to be asked to build certain systems at certain institutions, whether it's banks or startups and whatnot. And being the first person to have to build something sometimes can be a daunting task. But at the same time, it can be the kind of task which allows you or forces your brain to go into master builder, Lego mode, whatever you want to call it, where you theorize and you ideate and you spike and you build your own way of understanding how the system should be designed. Because what I've also discovered is the first person that goes and builds anything, it's going to be biased by their thinking, as you would expect. So then when someone else comes along and has to learn and evolve and take that system as a V2 or whatever, they never have the same thinking because they hadn't had to build that core thinking and establish those fundamentals when the system was designed in the first place. So I think being a good architect fundamentally comes down to having some core beliefs in how you go through the process of designing and understanding what the business and the system requirements are, the ability to think full stack and map from what the business requirements are all the way down to how that event is going to be written into Apache Kafka and all the paths through that. And everyone develops their own flow, their own methodology for architecting systems. I know I've got mine, but it's one of those things, it's experience helps you understand how you are as a thinker, and also it helps to have a moment of truth as to whether you think you're being lazy or not, or whether you're being fundamental, and whether or not you think what you're doing stands up to solid peer review, because that it's obviously part of the process that you should undergo to architect and build and design and understand systems.
So you mentioned that you'd have a different definition or list from 20 years ago. What would it be 20 years ago?
I think 20 years ago, it might have been reading specifications and understanding them. I think the way I think about systems these days is because I've done a lot more event-driven streaming-based architectures now. I have a natural bias towards that, whereas 20 years ago, I was more about service-oriented architectures and RPC and less about events. I think the eventing we were doing then was probably related to distributed caching, like Oracle coherence and the like. But yeah, I think it would have been more specification-driven. But mind you, it was 20 years ago, or 19 years ago, I was at RBS building one of the first compute grids.
Well, you mentioned something early on, and I think that's important to know, is specifications are one thing, and then there's the actual implementation of those specifications, and the two differ. And until you've cut your teeth on that, until you've had your first time where, well, why didn't that work? The spec says this. Yes. Then, so I would say that the biggest issue I've seen with architects in the past is a theoretical knowledge rather than ideally a theoretical and practical knowledge of them. But and then go ahead.
I think that's a really good point. And I can give you an example of that. So cloud events, I was on the cloud events committee during my time at Confluent. And I was like, yeah, cloud events make sense. They're an envelope. And we were going through the spec. And I was doing the mapping of the spec into, how we build cloud events and we support Kafka as a transport mechanism. And so I was looking at the Kafka transport binding. And it all made sense, and I wrote all the spec down. And there's obviously there's going to be lots of stuff in my thinking that's not always captured, which is why it makes sense to have a layperson pick that up and do the peer review process. But what happened is later on, when various implementations or demonstrations were actually executed for the Kafka binding, there were certain things which were lost. And they were relating to partitioning and a few other things. So while the spec was there, in some ways it was a little bit opaque, and that carried through into some of the implementation. So I think your point, I completely agree with it.
Well, good. So you talked about some really early work at banks. So for example, in your career, you were at Royal Bank of Scotland, Deutchebank. And there you were creating computing grids at those banks. What were these systems doing?
So what happened is I'd previously worked at ThoughtWorks, and I think at the time ThoughtWorks had they'd hoovered up a whole bunch of people, and then we're building the Dixon's PC World Curry system that runs through the UK. And a whole bunch of people were leaving ThoughtWorks to go into banking. And some of my mates were at RBS, and they said, hey, we're working on trading platforms, blah, blah, blah. It's really exciting. So I went and joined, not really sure what I was getting myself into, but it seemed like something that was different. And I thought I could take some of the agile skills and the pair programming and those kinds of things into RBS and help establish some good coding principles and ways of doing things. And then after I was there a couple of months, we started working on a compute grid for a credit exotics platform. And this compute grid was because, I guess you've seen The Big Short, the film?
Yes.
So this is going back to 2004, and RBS were running credit exotic trades, CDOs, CDO squared. So CDOs are baskets of CDSs, credit default swaps, and CDOs are collateralized debt obligations, and then that's like a basket of CDSs. So you have these complex financial instruments which are being traded. They're derivatives. They're not the underlying asset. So that's why it's called an exotic. It's not the real thing. And as you can imagine, something that's a derivative of something else, which is a derivative of something else, which is a basket of this, that, and the other, it's pretty hard to value. And it's even more difficult to understand the risk associated with market events impacting how that's going to be priced over time. And at that time, RBS were doing this in spreadsheets. And they would link all the spreadsheets from the trader desktops together. And they would click go, and they would have their own little farm. Anyway, RBS were in trouble with the regulator and said, no, this isn't production worthy. You can't run a business like this. It's other people's money. So you responsibly have to go and implement something that allows you to calculate the right kind of risk at scale, something that we will sign off on. So we started building a credit exotic risk engine, which would take all of these complex exotic trades and run different types of risk measurements, and so we were looking at credit curves and yield curves. So your yield curves are your currency curves, and your credit curves are related to various organizations like Merrill Lynch, who happen to be on one of these credit curves as a credit rating. And so these compute grids would go and do a whole series of complex math. And the math was involved in looking at the various different types of simulations of stuff that can happen. And the most common one, which is a brute force analytic, is a Monte Carlo simulation. And with a Monte Carlo simulation, the more compute power you can throw at it, the better the results are. And at the time, the first compute grid we had was, I think it was 100 servers, or maybe even less. And the first weekend we went live, 5 of these HP servers, which were brand new, had disk failures. We couldn't believe it. It was a complete disaster. So obviously things grew and became increasingly complex, but it was kind of like the new era of calculating risk in investment banking.
That is funny. I haven't talked to many people who've done distributed Monte Carlo simulations, but I mean, you might have heard the one I did, the Million Monkeys. That was basically a distributed Monte Carlo simulation. And then the step further is optimization of distributed Monte Carlo simulations. And that's a whole fun, interesting optimization. In fact, I wrote posts about here's some ways of optimizing these.
Okay. Yeah. The thing that we found, though, is as we were building these systems, the requirements became increasingly complex because we had to build reports. Some of these were regulatory, some of these were the trader assistants or trader desktops, and they had various kind of audiences. And sometimes you've had reports built from other reports, and then you had analytics being reused because you only had a finite set of resources to compute. So we started stashing some of the intermediate results in terms of trying to achieve some kind of optimization and reusing them with different parameters to run subsequent analytics and subsequent roll-ups and aggregations and build other reports. And so then we quickly found ourselves in the world of distributed caching, which obviously is Oracle Coherence, Hazelcast, and Grid Game, but we were building on Oracle Coherence at that time.
You also reminded me of something, a realization I had the other day, that banks are incredibly risk averse, which actually makes them do things that are incredibly risky, thereby inverting their risk aversion or causing the opposite reaction, where you talked about the spreadsheets. Very risk averse. Got to have this in a spreadsheet to calculate my risk, which is inherently far riskier than anything that they could have done.
Yeah.
Banks just crack me up like that.
Yeah, I think sometimes it's better not to know why some decisions were made, because you can go, oh my God, really? This is where we are, and this is how we got here, and now you need to dig us out of that hole. I'm not a fan of the Spring framework, because at that time, when I first joined, we had a trading system and it was all built on Spring, and the dependency injection just would go bananas. We had unit tests going through, and that would basically go and hydrate the whole trading platform just to fire up a unit test, because of all of these dangling dependencies which were being sucked down the dependency graph just to run a simple unit test. And one of the first jobs I had was to detangle the dangling dependencies of the Spring framework. So I have a scar in my heart for the work associated with that. So now if anyone says Spring to me, I say, see you later.
Yeah, and that was probably an incredibly rewarding, and everybody at the team was, CEO on down was saying, great job, Neil, you detangled us. No, those jobs are usually slogging, and nobody understands it, and nobody really cares. And then you do
not a lot
it.
of
No kudos. No promotion to senior principal or
no. Yeah, we did do some cool stuff, like all the distributed caching was quite cool.
Well, talk about more about that. So is that one of the biggest thing you learned about during the while creating these grids?
Well, what we used the cache for was building and deriving events. So the grids are largely RPC oriented, but then by making the output of that drive. So yeah, we fundamentally re-architected the way that the broker system would run by making it event-oriented through the use of a data grid. And that was probably the most valuable thing, because it slowly led us down understanding how the flow of these jobs and these tasks related to each other. And you quickly find yourself in the world of event-driven systems yet again.
Okay. And so we've touched on this, but banks are notoriously difficult to work at. What did you find worked well?
So when I was at RBS, it was small, and then I moved to Deutchebank, and it was big, institutionalized, and people had either been there less than a year or more than 10 years. And so because RBS at that time was small and friendly and everyone kind of knew everyone, we could just get on and do things. I spent a bit of time at RBS Sempra, which was a commodities trading company. It was similar, everyone knew everyone, it was small. But then when I moved to Deutsche we were building a large scale shared compute grid infrastructure. And that was difficult. And that was difficult because it was a lot more siloed. And some of these silos are effectively political land grabs to own parts of the organization so people can fight their way up. What worked well was finding something that would solve everyone's common problem, so they would see you not as a threat, but someone that would make their business have better value, or perceived better value within the organization. So I think that worked well. But we ran into 2008 with the GFC, and the whole team got fired on Christmas Eve. I had to tell my team that we're done. So it's a nice Christmas break, that one.
Merry Christmas. Yeah, it seems like some of the worst things happen over that Christmas break of, oh, wow, there's a big problem. And you're probably being charitable with the other modifier is it being a German bank. Yeah, that adds a whole extra level.
Yeah, Deutsche Bank was an interesting place to work at in those days. I imagine it's changed a bit. Hopefully it has. But I have done a little bit of work with them since, but that was more from the consulting side of things. So you're not entrenched in the organization. You're there to help people. not threaten people, I guess, with what you're trying to build.
It sounds like kind of came full circle of a lesson you learned while working there, that as a consultant that you and I do the same thing in my consulting. I'm not there to land grab. I'm just here to help you. My
Yeah,
success is your success. Let's all
absolutely.
work together, please. I'm not here to cash a paycheck.
No, yeah, you're there to build things and make things work properly, right?
So then from there you went to Logscape, and that was founding your first startup. What made you leave and start something new?
Um, what actually happened is when everything got shut down at Deutchebank, we realized that building shared compute infrastructure at scale is hard, and we couldn't find a single vendor that would do that properly. So one of the guys I'd worked with at ThoughtWorks, Damien Guy and I, we went and started building this technology ourselves. We had lots of ideas when we were at ThoughtWorks, so we would collaborate with Martin Fowler and whiteboard with him, all these concepts and ideas, and try to get ThoughtWorks to sponsor them. And at the time, it was a bit difficult. But anyway, Damien and I were good mates. We worked together at RBS and other places. Anyway, so we started building this shared compute infrastructure, which would allow you to spin up virtualization environments and schedule those based upon time or workload. So we had like a feedback loop, which you could hook into with your application. So if Coherence was finding it was under heavy load, it could go and the vScape would go and fire up more nodes on the shared infrastructure. Similarly, it could do it for Data Synapse. It could reallocate the grid engines to different broker ecosystems. So we started building this thing called vScape so we could allow compute grids to be shared and optimized, which was a big problem because you're looking at a couple of 100,000 compute cores trying to share and not waste expensive resources. But however, we did the rounds. We started partnering with this company called Excelian, who I later worked for. And Excelian, they got us in front of Bank of America and they said, yeah, this technology you've got about sharing compute infrastructure is great, but there's only two of you guys, and what if you get hit by a bus? We're like, okay, yeah, fair point. But the problem that we had is we didn't understand, we came up with the idea of visualizing it using the log data, because vScape would run across all your compute engines with an agent. And we had a distributed file system based upon like a BitTorrent. So you could deploy your application infrastructure or your applications using that. And then it would ship the logs, and the logs would be visualized using other stuff, all other services that we wrote on vScape. And so we were demonstrating vScape with this logging layer, being told that, no, we can't use you guys because there's too few of you, and we're not going to put the bank's heart and soul on this system you built, even though it sounds really clever. But can we use this visualization stuff? Does it lets you visualize and drill into and build dashboards and all sorts of clever things on the log data? So we said, yes, you can use that. And so some companies started trialing it, said, yeah, we would like to buy this from you. So we pivoted into Logscape. And so at that time, Splunk was just getting going. And we were aware of them and they were aware of us. And we did that early startup, you do a bit of marketing and we'll copy you, and vice versa. And we tried to do the VC rounds. We got to references with Sequoia, which was great fun. However, because our customers were banks, we were all on-prem. And at that time, the VCs were all into cloud. And we're like, well, we're going to lose our own customers if we go and spend all of our limited resources building a cloud product. So we had a good couple of years with Logscape. And we failed the VC. We got to references with Sequoia. They said, look, you get your run rate up higher, we'll come and fund you guys. I think we're doing about £500,000 a year at the time, pounds, which was okay, but they wanted 1 million on the board. And then the market shifted and, burned the candle at both ends for quite a few years. And eventually it was stable. But because I had worked with Excellian for a while, through Logscape, and I'd met them in industry. I joined them as their CTO. And so I had a couple of people working on Logscape. And then I moved into the world of consulting, so I didn't have to go back and become a permanent employee at a bank. So yeah, full circle indeed.
So would you do another startup?
Yes.
Why?
Yeah. Well, you're your own boss. If you can get a good enough team together. So there's a number of things that you need to build a startup. And if you can get it right, you don't do it for the sake of it. You have to have cause. And that cause has to get you out of bed. So, and if you don't have that, then you don't have the passion. And I don't know, I think you and I are a bit long in the tooth to be excited by, the next generation of XML coming out or something that, is a bit Mickey Mouse. So I need something to get me out of bed in the morning that makes me excited. And if there's a startup that does that, then I'm all in. So, but you've got to believe in all the things. And I guess that's part of why I joined Confluent. But, we'll come to that in a little bit.
Yeah, it's interesting you mentioned that. I was thinking about this the other day of there's not much that excites me about what's happening. And I think it's simply because a lot of what's out there is just either a rehashing or a rebranding. For example, some of the startups I saw at Big Data London were, hey, here's software engineering principles applied for data warehouses. I'm thinking, why weren't they doing this in the first place? And this is 20 plus years old ideas. Yeah. Are we really that backward as an industry? And the answer is yes to both, quite frankly, because they're getting sales and they're getting customers, but it's such a poor testament of data warehouse engineering and data warehouses that we have to do something like this.
Yeah. I guess that is the whole marketing FUD thing. I mean, you were at Big Data London last year, I guess, as well, right?
Yes.
Yeah. So, and it was all data mesh this, data mesh that, and I'm a data mesh, and everyone's a data mesh. And then this year is like, we're all Gen AI, and it's crazy, some of the marketing stuff. And I had a look at some of the data mesh startups that were there, and it's just indicative of everything that's wrong in tech, the whole data mesh thing.
So we'll talk more about that when we talk about SpecMesh. So you were there at Excelian, and one of your biggest projects was getting Azure adoption at UBS. Talk about that project and how you did that.
Yeah, so we would work across a whole bunch of different projects. Well, I'd normally be in charge of like 10 to 15 projects, unless a big one came along. And we were doing a lot of compute grid, distributed caching work. And we were doing a lot of work around, the latest stuff that was coming out around Kubernetes and DevOps and whatnot at the time. So we're talking like 2014, around that time frame. And then UBS wanted to get onto cloud. It's like any bank. They'd had some old data centers. The data centers needed to be retired. And they had this system, which I won't name, that had some fairly extensive compute grid requirements. I think it was over 200,000 compute cores that they needed to spin up, and they would only need them for a certain duration, which kind of makes cloud quite suitable. But obviously, you have the issue of how do I get all my data into the cloud when my source data exists within my own data center, and I just want the compute resources. So they'd already decided on Azure. I won't comment on how that decision was made, but Azure was the go-to. And at that time, Microsoft were kind of getting V2 of Azure going. And Microsoft they were a bit concerned about having this need to just be able to go and spin up a couple 100,000 compute cores on demand and it working. And one of the guys that was lead engineer on it, he was experimenting with Azure. And he says, I can fire up a scale set of like 10 or 20 servers. If I get to 50, 5 of them fail. So I'm getting a 10% failure rate. Get to 100 and the failure rate increases. And he goes, I don't know how we're going to get 200,000 compute cores running successfully, reliably, because what the requirement is not only to fire up the compute cores, but for the job that those compute cores are calculating to be finished at a certain time so that the derived reports can be built. So you can't run late as a regulatory reporting requirement. So we did hit quite a few rough edges on Azure in those days. I imagine a lot of the issues that we hit have been fixed by now, but it was a bit tenuous at times where we couldn't guarantee that anything was actually going to work reliably about 50% of the time. And troubleshooting that and things getting stuck and figuring out why they couldn't be unstuck and resolved. And then how do you observe all of these things, because it's fairly large scale and the observability infrastructure that was in place for it was rubbish. And if you had things stuck, then you couldn't rerun the same scale set to carry on. So it was tricky. It felt like we were working with half-baked technology to do production workloads that a bank had its regulatory reporting and big hefty fines hanging off the back of. So it was an experience. I'm not the massive fan of Azure as a result of some of my experiences in those days, but it gets the job done if you can treat it right.
Yeah, lots of ifs. I mean, your experience was similar to mine of Azure, especially around that time. Azure around that time was, and that was tough. That was really tough. It was, and so you're there in the middle as the consultant. Company's mad, taking the heat from the company, and then trying to get Microsoft to do something, which was difficult. Is always difficult working with the in that middle. Did you find anything that worked well being that man in the middle?
Well, that's a hard question to answer. I think what worked well was try and understand that they were addressing certain things, but the most valuable thing was having the right connection to the right person on both sides. So you don't necessarily want to speak to someone at Microsoft about why things aren't working unless they can guarantee you that such and such is looking at it and they're going to come back to you with the resolution of how long it's going to take to get fixed. So having this transparency inside what's actually being engineered on the back end of the cloud helped a lot. Because the first meeting that we had when we kicked this off, I think there was me and one other guy from Excelian. There were maybe 3 people from UBS and about 15 people from Microsoft who were quite excited by the deal. People had flown over from the States because it's a fairly substantial amount of money being spent by UBS at the time. And Microsoft wanted to get it right, and they tried hard. But if the infrastructure is not great, then the one thing that does work well is just having that direct line to who's fixing it and know that the problem is being solved as you speak. Because some of these timeframes, if they slip, well, the time frame was being dictated by a data center being shut down. So, and that was a hard shutdown as well, coming up to end of lease. So yeah, it was tricky, but having that direct line to the people that can make a difference and impact change, and having the transparency on how long things are going to take to get resolved and trying to come up with workarounds that makes everyone happy tends to be the way to kind of dig yourself out of that hole.
It's interesting that echoes a conversation that I just had with somebody about, we do business with people, whether it's consulting, whatever it is, it's a person on the other side of that. And that person on the other side, really their personality, how they work, how they communicate is the success or failure. And so if you have this chain of people that are pretty decent and, will work hard and try to communicate, you have decent odds of fixing this. if you have any chain, any person within that chain that isn't working well, you have very low
Mm,
odds of fixing that. And it isn't a technical issue; it's a people issue of that chain.
yeah. I think there's a saying that one of the guys I worked with at a hedge fund, and he said there's no such thing as over communication. It's very easy to under communicate or miscommunicate, but don't be shy of over communicating, because if you can over communicate and you can establish trust, which is obviously fundamental in all of these things, then you know where things are headed.
Well, speaking of heading, you went to Confluent after this, and where you were
Yeah.
a technologist. That's kind of a funny title in the office of the
Mm,
CTO. Why did you decide
mm.
to move to a vendor?
Well, so what was happening at Excelian? We were seeing an increasing number. So remember when I talked about compute grid? I said, there's a flow, there's all events, and we were starting to model compute grid as jobs and tasks and join points in Oracle Coherence as data flows. And then at the time, we were started to see more real time requirements around trader surveillance, customer 360. So we started seeing an increasing number of projects land that needed Kafka. And we could just see that becoming completely expansive. And when you're taking the stuff that you've built before at scale and you map it onto this other technology, you figure out there's, going back to what makes a good architect, you figure out, there's these other fundamentals which allow you to build a system in a more holistic and clean way. And we were finding that with Kafka. So my startup co-founder, Damien, was at Apple, and Apple openly talk about how a large part of their backend infrastructure runs on Apache Kafka. And he was making commits back into the source. And Confluent, who had spun out from LinkedIn, had their 2 million funding, working in, I think it was, I can't remember, one of the VCs, ground floors. They didn't have a proper office at that time. They noticed this and they said, "Oh, Kafka, do you want to come and work for us?" And I think when he joined, they had about 40 people. And I was talking to him about what we were seeing with Kafka. And he says, yeah, Confluent's cool. It's a startup. It's really small. And I said, well, okay, well, they're doing all of these things because I see that there's these gaps and I think there's this opportunity. And he goes, dude, look, just talk to Neha and tell her what you think. So I spoke to Neha and she said, do you want to come over?
Neha being the CTO of
And
Confluent at that time.
yeah, Neha being CTO. So she's one of the co-founders. There's Jay, Jun, Neha. Martin Kleppmann was instrumental in creating Kafka at the beginning at LinkedIn, but he had his own path to travel down. So, and Neha said, do you want to fly on over and have a chat? And I was like, oh, okay. She goes, can you be here for Monday? I think it was a Thursday. And so they booked tickets. I flew over. Saturday of interviews, and I was just like, okay, I'm going right over the other side to the vendor side, but it's large. It's all Apache Kafka at the time. The Confluent Control Center and a bunch of the other stuff was pretty more like marketing wear. It kind of looked nice, didn't do a whole lot. The company is still quite young, still trying to build out a strategy. So I joined, and initially I worked on ksql, which was a bit scary given the state of the code base. And I worked with the Streams guys, which was fantastic. They've got some real talent in Confluent. And then after working there for 6 months, I worked in the office of the CTO with Michael Knoll and Ben Stopford. And it was a bit of a head change for me because I'd gone from solving client problems to solving data infrastructure problems. So it was kind of like the bottom looking up, whereas before I'd been at the top of the stack looking down, trying to figure out how everything fits together. So part of my role there was trying to bring this outer world thinking of how the rest of the world brings things into Silicon Valley, which can be fairly insulated. It's generally a large NIH culture, which I get. But Confluent was trying to learn how they could build this technology, which was prolifically growing and being adopted everywhere and turn it into a viable business. So I joined Confluent, met some amazing people, and yeah, it was a really nice, really good time. Had great culture right at the beginning.
Good. Did you interview at the place that was right next to the dentist office?
Yeah, it's got the really funky floor plan layout and wood paneling everywhere. It's
Yep.
yeah, really strange building, but really cool at the same time. I like that building much better than their new one in Mountain View.
Yeah, that was where I first met them. It was just five people in a dentist's office. That's what I say is because we didn't cross paths when I was working with Confluent, but yeah, I don't think we met cross paths. But yeah, I was pretty early on working with them. That was I spent a lot of time working with Ewan and Neha
Hmm.
and
Hmm.
June. June's a great guy. I
Yeah,
haven't seen him in a
yeah.
while. So you,
Both like you and so much fun. I mean, I like Neha as well, but I've spent a lot of time hanging out with Ewan, and Jun's just a absolute superstar.
he is, and I saw him a few years ago, and
Mm.
still the same guy that I always knew. Didn't sometimes in the
Mm.
Bay Area or Silicon Valley it gets to their head, and I am now the hottest thing out there, and June's not that way. So
No,
I've yeah yeah
it's very down to
very down to earth. And so sometimes stories I've never told, so I was doing the training for Confluent, and
Mhm.
June, I did the developer training, and then June did the operations training. So we'd actually see each other in the airport sometimes as we cross paths at a company, and we'd compare notes, and yeah, it was good to. Those were the days, those early
Mm.
days of Kafka, and
Yeah, I think the early days at Confluent were what I think a good startup looks like. Everyone knows everyone. There's a very healthy collaboration of writing one pages and getting everyone involved and understanding where it's going. Yeah, really good times.
good. You mentioned a few things. Do you mind if we talk about that conversation we had about ksql, or do you want to skip that?
Yeah, no, we can talk about ksql for
Okay.
sure.
So you mentioned, so you and I have very different perspectives. You have an insider perspective, and I had the outside perspective where
Mhm.
I wrote a post, and frankly part of why I quit working with Confluent was because of ksql. I saw I'm not going to push this thing. I can't. I just can't. It's not good. And so you have this inside perspective. Let's compare notes. Why was ksqlDB so problematic? Let's put it nicely.
I think ksql is problematic because, well, we're going to go back to good architect, bad architect. Uh, when we started this whole thing, I think it was problematic because it wasn't designed with the correct first principles in mind from the ground up. If you can, it's a bit like building a house or designing a city or something. You have to establish all those core fundamentals of how everything is going to work together before you can build on top of it. And so that's real world architecture mapping into software architecture. And it's like anything, you need your network, you need all the things, all your clustering, domain orientation, all of these things that you take when you build any distributed system, you can burrow that down into something like ksql. And when those aren't first class considerations in the way the system is built, you can figure that out within, a very short time after looking at the code base. Because you have high degrees of coupling, uh, classes that should have been refactored that try and do 17 different things. It's very difficult to test. This just the health of the code base was indicative of the thinking that had gone into actually architecting it in the first place. So, and that, I mean, on your post, you talk about checkpointing and a whole bunch of other things. they're the kind of fundamentals you need to establish right at the beginning. You can't just plaster those on at the end.
Well, you mentioned checkpointing. Why was checkpointing so big?
Well, I just pulled out your post. I remember reading it back in the day. But I think, the goal of ksql was trying to provide a SQL, it was trying to break down the barrier for Kafka so it could be used by other people. But if you're going to put SQL in front of that, then it starts to kind of masquerade as a database. And then we start talking about event sourcing and offsets and how do I go back in time? How do I rebuild state? And then I remember when I did a blog post called Journey to Event Driven. And who was the Mr. Event Sourcing guy? Greg. Yeah, he did Event Store DB. But it all comes down to event sourcing, rebuilding state, and everything tied into that. It's one thing to have a stream of events, but it's another thing to actually be able to go back in time, build the state correctly, and where is that stored? You can't corrupt data. You need to be able to store, maintain, rebuild state.
Yeah, yeah. So in the show notes, we'll put the link to that post. But I think it was the only post that I ever saw about it talking about here is why it's bad. And I felt the need. So in my consulting, I had told people don't do this, but I felt the need to warn the world at large about, hey, this is actually a big problem. Don't follow this. And it definitely went against Confluent's marketing at that time of them taking it from ksql to ksqlDB, further saying this is a database, and that further confused people, and that drove me nuts, frankly.
Yeah, I know. Well, I think the whole Kafka thing has evolved to Kafka is now largely perceived as a protocol with the 17 million vendors touting a Kafka-based cloud service, whether that's, WarpStream, Red Panda, Confluent, MSK, Ivan, and others.
Pulsar.
But
Can't
now
blame Pulsar.
it's the whole protocols. And Pulsar, yes. Now it's the protocol. Now the next frontier. We're back at the whole ksql SQL over the Kafka protocol. So that's kind of where all the heat is right now. Obviously, you've got Decodable and not S3. No, you got S3. I don't know what their backend architecture looks like, but you got a whole bunch of them. The space is getting crowded. It's growing.
It's crowded, and it will more than likely follow similar sort of explosions and then contractions of market fit or inability. But you mentioned something that was important, and you said NIH. And for people who don't know what NIH, it means not invented here. It's a thing that I think plagues startups, but I would say Silicon Valley even more so than anybody else. And that is that unless it was invented in Silicon Valley or at that company in particular, it just either doesn't exist or isn't worth it, or I can do it better. And I think you and I come from enough background of understanding either long tail or so talk more about that NIH and that manifestation.
I mean, you would see this when you go into an organization. The first thing you try and do is understand what is the development culture. And sometimes that development culture can be we just outsource everything to another firm in India, or it can be we hire the best engineers because we need to build competitive edge. Or we give our engineers free rein because we don't really understand what they're doing and they can do whatever they want. And the latter is, I think, what we used to see a lot more of going back over like the last 10, 20 years, where there's a lot more free rein for people to play and have a bit of fun. Now, depending on the organization, you may or may not get away with that, but I think it's more kind of pervasive in Silicon Valley because it's largely an insular ecosystem where there's this disparity between what the customer really needs and what they think the customer wants, and then how they're going to build it and what is the rest of the industry doing. And I think places like LinkedIn and Uber and Netflix are all into the NIH, and that's a good opportunity for innovation. And if you have deep pockets and the business can sponsor that, then that's fantastic. But there's many layers which you can innovate. But it comes back to, are the fundamentals for what you need to innovate on available, or do you need to establish and build those fundamentals yourself? Because if I was going to innovate these days, yeah, okay, it would be on something over Kafka. I don't need to worry about that because that's been solved. And then I'd go further up the stack. But the NIH culture is good and bad, and it depends how the organization is run. So without it, we wouldn't have seen Apache Kafka pop out of LinkedIn like it did.
Yeah, there's you point out that there's good and bad to this, and so sometimes something interesting pops out of there wasn't something like Kafka out there, for example, and then at the same time you have several different of the same essentially thing at different popping out of these same companies, and instead of working together on that, and one thing that somebody said that I think really captures why this happens is you don't get a promotion for doing a commit or some small feature in somebody else's thing. You get a promotion because you create your own and you say how good it is, and that's how you become a principal or whatever level you want to get to.
Yeah, that's true. That's true. I mean, there's a lot of stuff that was built in the early days at Confluent, which was very NIH, and I was just like, we don't need to write all this. We could have just used something that's open source and off the shelf and would work in a simpler way and is actively maintained as an open source project. But I guess it's like, what's going to be the next successful startup? You can have a lot of NIH, but maybe only some of it's worthwhile. And some of it, you're just creating massive technical debt because you've got no one to look after it. It's just increasing the service area of responsibility and bug fixes.
Yeah. A cautionary tale. And so we're kind of talking about that in terms of Silicon Valley, deep pocket sort of innovation. And then every so often I'll be at some bank or some, in the case of US, sometimes middle America sort of company doing their own NIH. And I think that's a whole different story of, hey, that person who wrote that probably didn't think through this, doesn't have the level of experience to even do that. You're shooting yourselves in the foot even more so. So you just talked about that surface area, that person leaving. I've hit that. There's somebody's PhD thesis is running in production, and that person left, and that code wasn't good to begin with. So this NIH can really bite you.
Yes. Yeah. Yeah. Nice to have, but I guess the other thing is sometimes the NIH is just a complete and utter waste of time and more about ego for the programmer than the good of the company and the bigger picture. I guess that's the thing where it gets people enthusiastic, but at the same time, does it add business value or technical debt?
And although we're talking about Confluent, we've seen this in other companies. Cloudera had the same thing, quite frankly, when I was there. So it's endemic, I would say, especially to Silicon Valley companies. So did you have any other product surprises while you were at Confluent?
Yeah, I mean, we were trying to figure out how to defend against the elephant in the room, which was Amazon, because we had a fairly good idea that they were going to spin up MSK. So yeah, a lot of deep conversations around open source licensing, how to defend against that, how aggressive Amazon were going to be with MSK, and who else was going to come after the market to try and take ownership, and then how can Confluent build out their stack. So we also did quite a lot of competitive analysis, which is always interesting because sometimes you look at a company and you look at their website and their marketing, you think, okay, And then you go and actually meet them at a trade show like Big Data London. You start talking to them and you go, okay, obviously the two are completely being payrolled by the same business, but there's a different level of truth you get when you actually go and speak to people. And so the competitive analysis was quite tricky because you can look through the technical documentation and try and do some prototypes, but it doesn't actually allow you to understand the true cost of owning that piece of technology, or what the customer experience is like, where they're going on their journey. I think the other interesting things that we found, or I found at Confluent, was I would write a blog post and then a similar kind of blog post with a similar name or similar something would pop up on one of the competitors' sites. And I'd seen that at Logscape when Splunk and Damien and me were doing the Tango. Ultimately, we lost against Splunk. But I think it's just one of those things in the tech industry. They follow who they think is the leader. And the leader has this unfair advantage of trailblazing and investing in that thought leadership, trailblazing to, where does this go? And all the competitors try and just get in the slipstream to ride that tailwind, I should say. So, I mean, that was definitely interesting. I think the other thing that was quite unexpected was how difficult it seemed to be for most organizations to adopt this technology properly. Because if you break it down and say, hey, I have an event, that event is partitioned, and I'm going to have a consumer, and I have lots of consumers, and the partitions are going to be spread consistently between these consumers. So all these events are going to be delivered in order. Now, take these simple concepts and go and build a system over that and put them in topics. The mess that you can see some people get into is astounding. And I think it's scary that you can take a simple concept and the scale of disaster that can unfold from that is worrying. And that always surprised me when you speak to some customers about what they're doing and how they're going about it, that some of the decisions that they've made, it's almost like they dive in at the deep end of the pool without actually getting in the shallow end of the pool and learning how to swim properly. And some of those decisions can be quite difficult to unwind as well. So I guess that was the other thing. I thought the technology would be easier to adopt than it is, and it's not.
It isn't.
It seems like the world is still learning, and here comes data mesh and some AI stuff as well, just to make it even more busy.
Well, speaking of meshes, let's start talking about SpecMesh, and we're going to go into the whiteboarding and start drawing out. Cool. So would you mind whiteboarding out what SpecMesh is for us?
I'm going to talk about the principles of how SpecMesh came about, because it goes back into some of the discussion that Jesse and I were just having, or you and I were just having, Jesse, about the disasters that I've been experiencing. So I left Confluent when the company got to a reasonable size where the culture was starting to slip. I think we're about 1,500 people at that time. And with the idea of just doing freelance consulting and try and help as many people out there in the world of Apache Kafka as I could. Just as COVID hit anyway. So I would work on some Confluent projects and pick up my own independent work and then some MSK projects. But what was happening was I'd go to some places and I would see a topic, and the topic would have a spelling mistake in the name and it was still being used. And then I would see the same topic without the spelling mistake in the name, and it was also being used. And then I would talk to the company and say, well, how are you provisioning these topics? And someone would say, well, we're just doing it using the admin client, or we're using some DevOps tooling, or it's done by the admin, or it could be all three of those. And so what was happening was, and then the topic structure would just be a mess of, this is my hello world topic. And this could be in production. You just have random topics all over the place. And it was basically like a big, massive shared file system that people had free reign in. And I know there's one company that I met at Big Data London last year, and they have in excess of 50,000 topics and growing. And so these are some of the things that we see in the industry where there's lots of topics, there's no structure, and then more importantly, they don't know how to share the data between different parts of the organization. And then along come on Confluent and say, well, we're going to do this thing called events as a backbone, but then different parts of the organization are going to have their own events. So, this might be one part of the organization. We're going to have these common business events here in the middle. And we end up with I'm not trying to draw Mickey Mouse here, sorry, so I'm going to draw these on the bottom. And so these, you're into event storming, right, Jesse?
Yes.
So in domain orientation, so if we think about the functionality of an organization, it's not the organizational structure, it's the functional structure of the organization. So that's what falls out of event storming, and the functionality within each of those functional business units. And then we can break those down further and how they all kind of relate to each other. So you end up with...
Would you mind briefly defining what event storming is, in case people aren't aware of it?
So event storming is the process of understanding how a business describes itself. And so what you would do is you go into a room for 2 days with people that understand the business and everything about it. And you run a workshop where we say, well, we're going to try and figure out how your business, what they do, and how we think about the business and all the different parts of it, how they all relate to each other. So as part of this process, there's some really good books on this. And it's one of these things that it was big, I don't know, quite a few years ago, then it kind of got forgotten about. And then as we've moved more back into event-driven architectures, it's kind of come back because it makes a lot of sense. And an event storming workshop allows you to go and build a series of related events into sorry, my laptop's just interrupted me there. And what comes out of this are these functional units and the events that flow between these functional units and how they relate to each other. So you end up with this model of your business and how it relates and how it exists. And so this outcome is how you think about your business and how you architect it. And so what I always say is, once we have this domain orientation of how the business fits together, we can start building domain-driven design-based systems, which is fundamentally why we're here, because the right kind of large-scale distributed system, you're going to be able to take a slice of that domain, and that slice of the domain all the way from the microservices, the events between those microservices and how they relate to each other, put them into a bounded context or an aggregate. And then that bounded context is a functional unit, and that will sit within another domain. And so we can bring these out in multiple layers. A lot of the time you won't. But then we have this model for how the system is deployed, architected, and built. And I normally go down the path of, so I'm getting a little bit sidetracked. I will come back to SpecMesh because it does tie in with this. I normally go down the path of having sets of related services broken down in the same repo. So you don't go micro repo, you don't go monolith. You have a repo for domain unit or aggregate, or more correctly termed bounded context. And then you have your CI/CD pipeline for that. And then that will allow your black and white box testing, and that will allow it being promoted through different environments. At the edge of all of this, obviously, are events, and those events are business level events that interact with other parts of the organization. So I've covered a lot of ground there, but I'm trying to kind of paint a very broad picture of how we go from talking to business people to mapping it into our domain model-based microservices and infrastructure. Now, what you want to be able to do is mirror this domain orientation, not only your source code and your services, your repos, your build pipelines, but also in your data infrastructure. And that means your topics, and more specifically, the hierarchical representation of your topic. So when we sit it down and look at an organization that looks like what I've drawn in these circles, each one of these would be a functional domain unit that is relating to each other. And what SpecMesh does is it says, instead of having 3 different ways to provision your data resources in Kafka, is you're going to have a async API specification. And the reason we have an async API specification is because it allows you to tie together the hierarchical structure of a group of related topics, the permissions related to those, and the schemas related to those, but also more importantly, the metadata associated with that. And that becomes a specification, which is what SpecMesh takes and provisions. So SpecMesh will capture your domain model in the async API spec, and it will go and provision all the related resources. And then you take that spec and then you publish it into a data catalog so other people can go and discover your application and the metadata associated with that. So by the time you've got to a place where systems are being built and collaborated on, you're going to have events flowing between. Can I draw an arrow in here?
Just do it manually.
Oh, yeah. You're going to have events flowing in between the individual microservices, and then you're going to have some flowing out here into the shared events as a backbone, or whatever you want to call it. And then, because we're talking about choreography and not orchestration, you don't care or know who's consuming these events. Oh, I'm going to do that one. And that way we can start building something that can scale. So as the organization grows and other business units or other functional units are added, we end up with the ability to share data and, more importantly, evolve the functionality that we're building. I don't know how my drawing's going.
It's going good. You're doing it via mouse, which is more difficult.
Yeah.
So here, to help people kind of understand what's happening here. Here we have this domain unit, and I think one of the key issues that we realized I saw early on with Kafka is, especially using it when we're using it here for microservices, is that there's no ability to say this topic is just for these 2 microservices to talk back and forth. And so people could come and did start listening on this topic and saying, oh, I'm going to start using your data. And when you made this change between those 2 services, they said, oh, you broke me. Well, you weren't one of the consumers there per se. So one of the issues we had with Kafka was the ability to say, here's a public interface and here's a private interface. And how does SpecMesh deal with that?
So each spec is going to have a domain owner. So the domain owner is basically like a principal. So we might say we're going to have a bit like you do your Java packaging, right? So I'm going to move this guy. So what is, to do this quickly, we've got A.B.C. Terrible naming I should come up with, but we've got A. I'm not going to do that. I'm going to make it more real. I'm going to do Tom. This is HR. This is accounts. Trading. Now they all do different things. Everywhere has HR, everywhere has accounting. This has got the trading part, and then we have reporting, which does reporting to external customers. That might be, they might generate reports which need to go to accounts, which need to go to their customers. So what happens here is within each one of these, within accounts, where we have public data that's going to be shared, with SpecMesh, we can say our topics are going to end up being called. I have a couple of options here. Public, and then we can say invoice. So we're going to make our invoices that we've published publicly available. And that invoice might be consumed by HR because HR have sent an invoice to someone and they need it chased up, or they've sent an invoice to someone that works for them, or something like that. Com.trading have some intraday affected. Some intraday data that's good. And this protected will have metadata associated with it, which grants access to com.reporting. So anyone in com.reporting, and only those in com.reporting, anything that's public, like it is down here. So anything that's public, like down here. How do I do the marker like you did?
It's there on the left. It's the
yeah.
It's the laser. There you go.
So the laser, I like that. So anything that's public like this can be shared and accessed by anything. And what SpecMesh will do is when you provision this specification for com.accounts, it is going to put the ACLs in place, and the ACLs will grant public access to this topic, or public read-only access to this topic, and it'll allow write-only access by this principal or this domain owner. So any one of these can consume the invoicing information, but only com.accounts can write the invoicing information. Now within here, we also have those events which we were talking about a second ago, which are within com.hr. So we might have private. And so these are the name of the topic. So stuff that's private obviously can only be read or written to within this bounded context. And so that might be new employee or something. Might be part of the onboarding set of services, which are sharing this new employee data. I'll just pop this up the top here. Whoops. And so when the SpecMesh provisions, the ACLs will be in place, so it's private. Now, all of these things are quite important because when you're building event-driven systems, you want to control who has access to what. And the competing contradiction of this is the concept of choreography, is you don't need to know who consumes your events. You can pop it out there. So my invoice can go out there, and that can go into reporting, it can go into trading. So the invoice can be published, trading can react to it, reporting can react to it, and logistics can react to it. And in each case, you don't have to care about it. But there is a responsibility for something that is public, and the responsibility for something that's public is the schematization. So SpecMesh will provision this topic. It will put the ACLs in place so it can be consumed. It will also publish the schema associated with this and do a schema validation check. So if the schema does evolve, it's not a breaking change. So hence we can enable choreography. You're always going to have private sets of events, which the outside world should not see. And it's up to this domain owner and this set of services within this repo as to whether or not they think it needs a schema. Maybe it doesn't. Maybe this is a topic that's always drained or you don't care about. So hence, the fact that it's private has massively different connotations as to how it's treated. Protected, on the other hand, is obviously going to be something that's not going to be widely accessible. You want to control the access of who has it and what they can do with it. So in some cases, it might be masked or desensitized, but protected is, again, something, it's a little bit more costly because you do have a set of ACLs which are literal. So the ACLs in place for this are prefixed, which are not expensive. Similarly, for this, it's prefixed. So you can have any number of private topics and you're not going to need new sets of ACLs. Similarly with public. But if you have a large system with thousands and thousands and thousands of topics and a lot of them are protected, you're going to start getting a higher growth with your protected ACLs, which can slow down your broker infrastructure. I guess that's the one thing to be aware of. So what we've done now is we're saying we've got self-governance in place because each one of these teams can have a pipeline which they commit into. So they commit this into their CI/CD pipeline. It goes through, it gets promoted all the way into production until it's here and everything is provisioned. The next challenge that a lot of organizations have is like, they say, well, okay, now everything's really well structured and we know who owns what. If you take everyone's specification, you can actually build a topological view because this guy is actually subscribing to this public invoice data because in his spec, he's going to have a consume as part of the AsyncAPI spec. You can build a topological view of how these all relate to each other, even though we're enabling, the event-driven concept of choreography. The problem that you have then in most organizations, which SpecMesh overcomes because of this modeling that we're talking about, is how do you charge fairly for production and consumption of events? Because if I'm pumping out 2 invoices and it's being only consumed by this guy, then surely there's a shared cost between this production and this consumption. And I have been on so many consulting calls with so many different customers and so many Slack conversations is how do you build this? The reason it's difficult to build is because most deployments don't have this kind of basic traits. So the ACL that's granted here with protected, it uses the principal. So the principal in each one of these is com.accounts, com.hr, com.trading, which also means the consumer groups within here use the same principal. Now, provided that these consumer groups use the same principal to be granted access to this data, then you actually have an understanding of the consumption. So SpecMesh will also has, aside from the provision command, it allows you to do a production and consumption metric reporting on your specification. So I can take the com.accounts spec YAML, sorry, I just tapped my mic, and you can do a produce consume or production consumption report, and you can run that into anything or anything that can take the JSON that's popped out of the back of that and start implementing chargeback. And then you have a system that can scale across the enterprise. You can enable self-governance. In the case of protected, you might want to put in place a system where it's published into a data catalog, and then the data catalog, the potential consumer can look at the data catalog and say, hey, I want this intraday data because it's been annotated with this metadata that says it contains FX or some other kind of thing that I need to get access to. So then they can request access from the team that owns the data to provide a grant tag on that spec and push that spec and have the ACL updated. So then we have self-governance, we have metering and chargeback enablement, we have structured hierarchical topics, and we have a GitOps-oriented approach to provisioning Kafka topics, which means there's only one way rather than three ways.
And that is the way it should be. I know when, since we talked about the early days of Confluent, this was one of the first questions I would get sometimes of, okay, great, Kafka's great, API learned. Now, how do we go about doing this? And it was all these things were missing here. So it's just a immaturity issue oftentimes for the technology. So let's say I'm sitting there and I'm thinking, okay, I'm at let's say a smaller company, no chargebacks. Would you recommend something like SpecMesh, or do you think that's overkill for them?
I think it depends on how many services you have and how much data you have. So if you have like 20, 30, 40 microservices, and you've got schemas for each one of those, and you've got metadata for those, then I think it makes sense. But maybe you don't care about the governance and the controls. Maybe you just care about the provisioning mechanism and the publishing into a data catalog so you can achieve some kind of sharing and discovery of the data, because that's as important as understanding what is the nature of the data, and that's where data catalogs come in. So then you start down this path of, well, we're actually starting to build a data mesh because we have event streams, they're structured, the schemas can be annotated with metadata, so I can mark things as PII. So, and even small organizations are going to need to implement GDPR, right to be forgotten. So I guess the thing is, do you want to start the right way, or do you want to kind of start your own way and see how things unfold? Personally, I would start anything using this approach, but maybe not.
Well, let's dive deeper into that schema. So you and I had a conversation at Big Data London about schema. So to kind of educate people, the schema that often is talked about is, worst case, it's JSON. You have this JSON thing, and that's, people take that as enough schema. That isn't. You're going to give yourself a lot of problem that way. Then we get to the next level where it's an Avro type, maybe it's a thrift type of schema, protobuf, where we say, here's a field and here's a name for that. And then there's a whole other level of, this field is a phone number, or this field is PII, and this field is something, and we need to deal with that a different way. And that that third one is something that doesn't exist out in open source. Confluent talked a little bit about it at Current, but I didn't see a lot of detail on it. So I'm curious if that's going to be open source or what that's going to be. But it is a necessary thing that's out there, and it needs to not just be within the Kafka space. It needs to be within all the other things that consume and work with that. So Flink, Spark, it's a big deal, and across language too, frankly. So how do we go about dealing with that?
So there is, I'm going to try and, I think it's, so there's the Data Hub project, which you're probably familiar with, which is an open source metadata data catalog. And what you can do with that, you can take you can attach metadata to your Avro and your protobuf schemas. There's a mechanism for it. And then you can take that metadata and publish it into something like the Data Hub, which allows you to search and find different schemas based upon the fields and the annotations associated with them. That's still non-functional. That just still is supporting the discovery side of things. So it doesn't provide you with the solution that we're talking about, but it does provide you with part of the infrastructure to search, discover, and kind of figure out governance side, the governance side of things. So SpecMesh can be used to drive into the Data Hub API the specifications. So now we're getting to the point of where we go next. And the problem with that, the problem I see with all of this is Kafka is a protocol. And the only way that you can implement something that prevents the data from getting to the client is by integrating the right types of governance rules like masking into the protocol itself. Failing that, you're going to have to do what lenses tried to do back in the day, where you only access it through their client. So as you're aware, with the AsyncAPI and the Open API, which previously was called Swagger, you've got code generation. It would, and I'm talking theoretically here now, because this is potentially something I'd like to see built on SpecMesh further down the path, is it would be possible to co-generate a client against one of these topics using the schema, and it's all typed, and it would be a signed jar. And the signed jar, because it's typed and it knows who it is, it could look at the schema and it could make those data masking concerns itself and filter out the data accordingly. But it does need to be something that is controlled in a way that is secure. The only other way of doing that is you put it behind a service, and the service on the other side identifies who the principal is, and if it's the invoice data, and the invoice data has address information that's been denoted as PII, then at that time, before returning that data to the client, it masks on the fly. And the only other way that you probably do it right now is you write different versions of the same topic for different clients to give them access to. So you desensitize the topic on write, or the topic data on write. So they're the three possible routes you could go down. You provide a assigned client that's authorized to carry out the masking on behalf of whoever's using that library. A service is a backend which identifies the principal and masks it accordingly. Or on write, you control who has access to the topic. None of them are perfect, but I've seen all of them implemented in various organizations.
Yeah, it's kind of a weird thing. It's something that needs to happen at the broker, or
Yep.
or the way I've seen it done, for example, at Conductor, is you have a gateway. It speaks back to your point, the Kafka binary protocol, and maybe this is the way we need to start doing this. Is we also have it with Cora from Confluent Cloud. I'm not sure how they're doing their governance yet, but it is a possibility where we just say we can't do this in 20 different languages. We'll do it once the right way, and we do that at both the producer and consumer levels, and as a proxy in between. Is that what
There
you're
is one
leaning
other way.
towards?
Sorry, Jesse.
Oh, I was just saying, what do you think that that's a viable way?
Yes, I think it is. The problem is, and no, just there's one fourth way which I'd forgotten about. And this, I think Shopify do this with PII. They use crypto key tokenization. So again, you still need to talk to more infrastructure to get access to the field, whether or not it's masked. So you get a token, and then you have to figure out what that is by making the request, identifying yourself. The problem with all of this, and is what you said, is you go to any larger organization and you still see Ruby on Rails, Python, and different languages and different infrastructure and 17 different ways of trying to do the same thing, which pushes the point of solving it further back into the fabric of the infrastructure.
Yeah, and I think that was one of the early on, I think, underestimations of Kafka was just how dumb the client is and how dumb the producer is, and overall how dumb Kafka itself is. It's bytes in, bytes out, bytes stored, does not care. Even to the point where people didn't realize that the schema validation doesn't even happen at the broker. You could poison pill if you wanted to, or either by nefarious means or whatever means you wanted. You could put something in there that didn't adhere to that schema, and you could break downstream, because not everybody thought of that, and it would just keep retrying and would get stuck. So Yeah,
Yeah. Yeah.
there's a lot to this, and I think a lot of it comes down to we solve it at a central point, we solve it once, we solve it organization wide,
Mm.
and I think it's overall a better way. And
Mm.
more importantly, it's a way that you can do it without a bunch of code changes everywhere.
Yeah. Yeah, that's the thing, and it kind of goes back to, and this is why one of the first things I say on SpecMesh.io, SpecMesh puts an opinion on Kafka because Kafka doesn't have an opinion itself. It's bytes in and bytes out, like you said.
Yes. Yeah, and I think that's a good way of talking about what SpecMesh is. Let's put some opinions on something, and
Mm-hmm.
and these aren't just your own opinions. These are pretty well known best practices of how should you do this.
Yeah,
You talk.
it's funny. Sorry,
Go ahead.
I was going to say it's funny. I was at Kafka Summit London back in May or June or whenever it was, and I talked to a lot of people in the field of streaming, and everyone's like, "Yeah, you need an async API spec. It just makes sense." Because there's nothing out there that will provision Kafka infrastructure from an async API spec, but people will use it to document their Kafka infrastructure. And I was just like kept tripping over this, and everyone I speak to, so SpecMesh has been in development for a year now, and it's at a point where I've been trying to work on some blogs to explain the value proposition about how it puts an opinion over something that is largely unopinionated and allows you to use it in the right way. And anyone that's used Kafka in anger is like, oh God, okay, this makes a lot of sense. This is kind of, we wish we'd started out using this before we got to where we are now. So it is just something that is, there's never any way of, why would you do that? Everyone's like, yes. So it's kind of the point we're at now is we're starting to get, some adoption from some large organizations out there, which is good because it's an open source project that we work on in our spare time. So someone using it gives you a bit of a kick in the backside, which is welcome. But you need people to use the technology to figure out where you want it to go. Because the idea of taking this and provisioning Kafka topics and making it discoverable through a data catalog and allowing organizations to build a streaming data mesh, or kind of agreeing what they think a data mesh is, like the 4 pillars, whatnot, is exciting. But there's also, what do we build next? And we need people to use it. But I mean, for me, the principles around open API and open standards is one of the things that you need with any technology to allow it to make sense. And we're going full circle right back to the beginning of specifications. It's funny that.
So speaking of specifications, I want to drill into that. If you could go to the next or to the second whiteboard, you've talked about this async API a little bit. Would you mind whiteboarding out exactly what the async API is and what does that give you?
Okay. I'm trying to figure out what it is. So the async API has got different parts to it. And I'm trying to figure out, I'll draw this in. Can I draw squares? Yep. So you can have your core spec. At the top of the spec, you have some of the core elements, and the core elements are going to be, can I add text into that? I'll come back and I'll draw the text in a minute. And I'll also talk about what I disagree with. So this first section up here will have the ID. And what we normally do, but the async API spec is an open specification for describing event-driven architectures. This could be RabbitMQ, it could be a bunch of other things. And so the terms that it uses are not wholly specific to Kafka, they are more generic. It's definitely a project that is on fire in terms of adoption and attention. Their logo is building the event-driven future of event-driven architecture, and it makes a lot of sense to adopt an industry standard. And if you have a look at the top, you're going to end up with what you would expect only spec, which is, let me make that wider. I will delete some of this to make it fit, but you end up with a version of the spec, then you have some info. You normally have an ID. The ID is one of the things that SpecMesh uses, and the ID will be the principal. And when I say principal, I'm also saying it's the domain owner. And I'm going to go over this a little bit. It's the domain owner, which means it's also maps into domain orientation, which we talked about. It is also going to look like something like com.hr.onboarding. So this might be the onboarding part of HR. And this might be onboarding services. Right, so this ID up the top here is used in SpecMesh to know who owns it, and it's also used as the principal. It's also used as the topic prefix. It's also used with the group IDs or the group prefix for consumer grouping. This allows us to put governance in place for all of the things. The other thing that is in here, which I disagree with, I don't know what your opinion is, I'd like to get it, is they have this thing called environments. And in the environments, you can have the broker URL, you can say what the broker URL is for staging, and a whole bunch of other attributes. I fundamentally think this is wrong. This has been inherited from the open API. For me, I think it's wrong because I think of the spec as a data model. Data model does not have infrastructure in it. And when you have environments, that is your infrastructure. And if you're going all in on GitOps, your GitOps pipeline and your build promotion is where the infrastructure configuration is controlled and contained, because that's where your scripts for deploying clusters and all the other stuff is going, and your connection and your security keys, all those other things are going to be held. So if you're going into AWS, you're going to have your key vault with your keys and your configuration and your principles and all these other stuff. And normally your pipeline will read that out of environment variables to drive your Docker containers, which means it doesn't belong in here, in my view. What do you think, Jesse?
I would agree with you. That struck me as odd when I first looked it over, and I thought, why are you putting in basically environment variables into something that isn't really variables? These are things passed in as arguments to the Docker container, or they're coming from elsewhere. Should be coming from elsewhere.
Yeah.
The other thing that you're checking this into source control. So as you change these environments, now you have to go through and change a bunch of things in source control that shouldn't be changed.
Exactly. I am just opening another spec I've got over here. So then the thing that we have a bit further down the line is, here's an example of servers. Okay. That's just, for me, that just screams no. But anyway, I'll take that out. So I don't believe that the service thing actually makes sense. Now the thing that you can add next is called channels. So we have channels, and the channels in SpecMesh. I'm going to have to cut some of this down because it's going to be a bit big. Again, has this environment stuff which doesn't belong in there. Here we have what is called the Kafka binding, so we can see it better. So these Kafka bindings here this is a topic. Now, when this gets provisioned, you are going to end up with a topic that starts with com.hr onboarding ._public user signed up. This is the topic configuration. So everything owned by this spec or this domain ID will be prefixed with com.hr_onboarding. The ACLs get created according to this field here. The topic gets provisioned using this configuration in here. And then a bit further down, we have publish information. Let me go back to this. And the publish information, which is inside the channel, contains some metadata, which can be quite useful. So you can have summary information, the operation ID is, more information about the binding. The AsyncAPI goes quite fancy in terms of describing where the ID is going to be held based upon which schema registry you're using. But ultimately, you won't really need to worry about any of that based upon which serialization, deserialization you're using, because you're going to have your schema. In this case, we've got an Avro schema that's being referenced. So the publish information down here is one section. So this is topics that you're going to be publishing. See if I can move this guy. And then after that, you also will have consumption information. Now, I haven't put anything in here based upon, right, here's consumption. Oh, I've got a nice small font there. Sorry about that. And this is a topic that's being consumed from Acme Simple Range Transport Public Tube. So you can see it's public data that we don't own, we're subscribing to. And there's a schema associated with that. The thing I haven't talked about is the ability to add metadata to all of this. So your schemas can have metadata. Each one of your channels, your publish and subscribe, you won't have metadata attached to your subscribe, but you'll have it attached to the publish side of things.
You have info all the way down to the group ID, the consumer group ID.
Yeah, so then once you've done all of this, so I'm just going to chop that out, move that back over there. So then once you've got all of this, you've got stuff that is systematically the same across your consumers, your topic structures. When schemas gets published, the subject is prefixed with the topic name. So when you look in schema registry, you can see who owns the topics, which schemas are associated with which topics. And then you would take all of this as a spec. Let's just see if I can actually paste the spec in here. You could take all this as a spec and publish it into your data catalog. Make that a bit bigger. But you can't really see that, so I'll drop some of the stuff out. You get the idea that
you may need to click out of it so that it shows up on my side. Oh, there it goes.
So you start to get the feel for it there. And there's a whole bunch of tools with the AsyncAPI for editing them and navigating them. It's like a workbench, which means you're not just stuck in the world of text, and there's plugins that plug into IntelliJ. And then if you have a look at the AsyncAPI spec, you'll see the hundreds of tools that are out there. So the studio is quite good. So AsyncAPI Studio is, if you just go to there, then you can pull in your own YAML from your own Git location into the AsyncAPI Studio. It's quite a nice little workbench, actually. So there's like a rich ecosystem of tooling around this as well.
Interesting. Okay, well, is there anything else about SpecMesh that you think that we should know about?
I think the thing is, I think we talked about data contracts, where that's going, and then the roadmap. I think you and I were spitballing about, having a RESTful access to topics. I think that's something that we're kind of talking to a few people about, how they might use that. Because if you could spool topic data off onto block storage, make it available through a REST endpoint, then you could potentially do some of the masking stuff that we talked about. And yeah, that's it really. We've got quite a bit of engagement in the community, and we're just trying to keep pushing it forwards.
So if somebody wanted to go start poking around on SpecMesh, what would you suggest they do?
The quickest way to get going would be to have a look at the GitHub page, and there's an Apache Kafka quick start, which allows you to fire up all your Zookeeper and your brokers and your schema registry locally in Docker, and then run SpecMesh through Docker as well. And that just walks you through the different commands for provision, and then examining the schemas and topics that have been published and looking at their configuration. And that's the place to start.
Oh, good. So I have one real sort more final question for you, and that is, do you have any suggestions for how people can use Kafka more effectively? Probably bent toward banks, but how can people use Kafka more effectively?
That's a hard question. The problem with using Kafka effectively is making some of the simple decisions right in the first place. For me, it's about establishing your developer workflow and your build tool automation. One of the biggest challenges you have with Kafka is testing, because people think they can just plug everything in and it just works. And the testing and structuring your code base properly falls apart. And yes, you can use test containers and you can spin it up, but investing properly in your CI/CD, your testing methodology, is probably the best place to start, so you don't start rolling things out into production without the right guardrails in place. And obviously using SpecMesh as part of that.
Yeah, we didn't talk about that, but testing is near and dear to my heart as well. I don't believe that there was enough testing of how do you test a producer, how do you test a consumer. You should be able to narrow down issues pretty fast if you've done your unit testing correctly.
Yeah. Yeah, I mean, it's a massive issue. I mean, as long as I've ever worked in anything to do with data, it's the thing that's kind of the last talked about. It's a bit like security. No one wants to talk about it, but everyone knows they need to do it. So I don't know, I'm a Java guy myself. And I think a lot of this is to do with how you build your services. I mean, I've built some fairly extensive systems in Kafka Streams, and Kafka Streams has a reasonably good topology test driver. And the problem that you've got with a lot of the Kafka stuff is you need the infrastructure for it to talk to, but then you need to understand it's going to fail at different places. It might fail because it's failed to deserialize something because the schema's broken, or someone's put some rubbish in there. So then how do I How do I test that? And if it fails halfway through, not at the deserialization phase, then does it go into a dead letter queue? Or on the way out, maybe I've lost access. Does that go into a dead letter queue? And then how do I handle that? So there's a whole bunch of things around testing and catering for failure scenarios, which is a fairly large conversation.
It is. It is perhaps a conversation for another time. Well, Neil, thank you so much for coming on, talking about your experience and talking about SpecMesh. You shared so openly. I really appreciate it. Thank you again.
Thank you. Thanks for having me on. It's been great.